So to help you with your revision into databases, I'm going to go through the PowerPoint I've already taught in school. So for some of you, this will be a nice recap. For some people, maybe this is the first time you've ever heard of it. I don't know. So I'm going to break this up into chunks because there's a load of theory to go with databases, and if you have it all at once, it can be a bit much. So we're just going to go through the database terms that you need to know about and the idea behind a relational database in the first place. So um, the most simple way to store data is to basically have a table. Okay, so you can imagine it's a table like you'd write in your books or see in a textbook, and you've got your columns and you've got your rows and all the data within that. We call this a flat file database. Now, the problem with flat file databases is that they're not particularly very useful. Okay, so they're fine for storing a small amount of information, but if you want to store anything significant, then they're just not suitable. So if you can imagine the database behind maybe Amazon or eBay or any of those big websites, they will have hundreds of tables which they're going to be using and all linked together. So flat files are not suitable for that purpose. Now, a couple of key terms to bear in mind. So when we say the word record, what we really mean is a single entry in a table. So for example, if we say one record in this table would be maybe Bert here. Okay, you can see my expert highlighting there. So that'll be considered a single record. On this PowerPoint, I've got the word aggregate data, get my words out, aggregate data, and that's actually a really important term to use. It's not an English word that you use very often, so I know some students will kind of go, what on earth are you talking about, aggregates? Aggregate is essentially where we have more than one piece of information kind of put together, aggregated together, so put together. So here I've got interests, so Sally's interests are music and computing. So those are two things put together, and we're storing it in what we'd call a single cell, a single block information. Now, in database theory, that's actually a really bad thing to do. There are many reasons for that, which we'll get onto later. But when I say aggregate data, that's what I mean, and that becomes really important when we start looking at first normal form. Okay, so those are some initial kind of ideas. Now, the next really important concept is something called a primary key. Now, primary key on the basis of it is a really simple idea. Essentially, is a unique value for every single record. So in this case, if we look at name, you can see name has got a different name for every single record. Now, on the face of it, that is unique because they are different, aren't they? However, name would be a terrible primary key if you think about how many people are called Bert in the world, and Sally and Akeem and all the other names you can think of. So name would be a terrible primary key because it's not unique. Okay, if you could imagine signing up to Amazon, for example, and used I don't know, your first name as your username, it wouldn't work, would it? Because everyone's got different. Well, everyone's does have different name, but potentially those names might be the same. So we need something unique. So in a database, there has to be one attribute, one column, which is unique, which we call the primary key. And this allows us to first of all find the record really easily. Let's go back to our Amazon example. When you log into Amazon, you'll use your email address, won't you? That email address is unique to you. No one else can have the same email address as you. Therefore, because it's unique, we can use it to identify you. Okay, so in order to identify a single record in a table, we must have that primary key, and that becomes really important when we're searching through databases, when we're linking two tables together, which I'll come on to later. So we must have a primary key for every single table. Now, sometimes we might have a situation where we use two columns, two attributes, to make up the primary key, and we call that a composite primary key. Okay, composite to basically mean it's combined together, it's made up of two keys. Now, composite primary keys are possible. In my experience, they aren't used as much in the real world because it takes a little bit more kind of faffing around with when you're programming. So they're not as common, but they are possible. Okay. So in this example, we are using name and surname as a primary key. Now in this case, I could have two Berts. I could have Bert Smith and Bert Jones. Now that is better, okay, because we are less likely to get kind of primary key collisions here. However, there are definitely people with the same first name and surname out there in the world. Okay, so again, it's not a great composite primary key either, but we can combine them together. Now, really the focus of this is relational databases. So a relational database is where instead of having everything in a single table, flat file style, we actually break it up into smaller chunks, okay? Those tables will kind of contain one bit of useful information, okay? So for those who study object-oriented programming already, you already know about the idea of a class, okay? The thinking is similar, okay? So we might have all the data to do with the students in one table and all the data to go with a class, as in the class they attend, in a different, not class in object-oriented programming. Now, those are related though, okay? So a student will go to a class, so they don't own the class, they're not the class itself, but they attend the class, don't they? So there's a relationship between the student and the class. So that's where relational database is in, okay? Where we have two blocks of information, maybe two records, and there's some form of link between them, some form of relationship. So I might own a DVD. Okay, for example, there's a relationship between me and the DVD. I have a job. I have bought an item from a shop. Yep, so those kind of relationships with something else can be represented using relational database. Okay, and in a relational database's terms, we'll have those two separate ideas as two separate tables, or we call them entities when we're designing it, and we'll then link them together. So this diagram on the screen, you can see it's kind of got a line here, and then it's going to kind of these, I call them crow's feet, but you can call them many side if you want to. I prefer crow's feet because they look like crow's feet, as you do. So what this diagram basically saying is a class will contain many students, but a student will only be in one class. Okay, that's what this diagram is saying. Now I'm fully aware that a lot of you are saying, hang on a second, I go to many classes, Mr. Hamlet. Yeah, obviously you do that, but for this example, we're just saying a student goes to one class and one class only. Okay, so that's what this diagram is showing, and we'll use this diagram to very quickly show the relationships between different things. This diagram's got a special name. It's called an entity relationship diagram. Okay, now that term entity I'm going to go into in a moment. When we link two tables together, we need something called a foreign key. Now the foreign key's job is basically to say, well, okay, I've got one record in this table and one record in this table. Okay, the foreign key is basically saying, well, which one am I related to? So if I've got a table of classes, okay, so I might have physics, chemistry, computer science, math, blah blah blah, okay, and a student belongs to one of those classes, well, we need to say which class, don't we? Okay, so a student might be belonging to the computer science class or the chemistry class, and we need a way of basically specifically saying, okay, Joe Bloggs goes to chemistry, okay, Susie goes to computer science, okay, whatever happens to be. And that's the foreign key's job. Okay, so the foreign key allows us to link two tables together. Now the foreign key will link to the primary key of the other table. And the reason for that is because remember about the purpose of a primary key in the first place. It's a unique value, isn't it? Okay, so if I want to say I go to a specific class, well, I need to be able to uniquely identify that specific class, because if I can't and it's vague, I will be belonging to the wrong class, won't I? Or more than one class, which is even worse. I don't want to go to more than one class, do I? So the foreign key will always point to a primary key. Okay, and the reason for that is because we want to say specifically which record we're linked to. So let's see this in the end. So here I've got some classes. So I've got computing, maths, and physics. Okay, now my class table has a primary key. Okay, CID, class ID. Okay, you'll get used to me putting CID So ID for identifier and C for the name of the entity. Okay, I just like doing it that way. You'll see different ways on the internet. It's personal preference, personally. Anyway, in the student table, we also have a primary key. Okay, the student ID. Okay, SID. So each student ID has a different ID. Okay, that kind of gets away from the problem of having that composite using the first name and surname, where there might actually be two people with the same first name surname. So it gets rid of that problem just by adding on a new attributes and just making it a unique number. Okay, that is well and truly the easiest way to do primary key in databases, and it's very, very, very common. So let's actually read this now. So here we've got a foreign key. Okay, notice the foreign key in the student table is called CID, class ID. Okay, and that's exactly the same as this. Okay, so the foreign key will point to the primary key of the other table. Okay, so Sue Smith has a SID of 1, so that's her ID, and then she has a class ID of 1. And if we follow that arrow down, you can see in the class table the CID of 1 is computing. Okay, and Darren Jones also goes to computing. Okay, you can see he's got the same CID. Now notice the SID, the student ID, is different because that must be unique because it's the primary key, but the foreign key might have the same value because we might have more than one person in the same class. Okay, and that's how we manage that relationship. So the foreign key points to the primary key of the table, and that's how we link together. Without the foreign key, we wouldn't know who's in what class. So some of the definitions. Okay, a database is a persistent, organized and related store of data. So the word persistent basically means that the data is stored. So you can imagine if I had a database where it wasn't persistent and I switched the computer off, or there's a power cut or whatever it happens to be, and all the database was lost. Okay, that'd be terrible, because imagine this was a bank or Amazon or whatever, orders would be lost, money would be lost. That just cannot happen. Okay, so it must be persistent. So any change made to the database must be saved immediately, otherwise we have a problem. So it has to be stored on something permanent, like a disk or SSD or whatever happens to be. It needs to be stored somewhere. It has to be organized. It has to be in a predictable way. So this is where the tables come into it, and that relationship between the tables, and that's the focus of really this unit, is how is data organized. So the next thing really is to look at the difference between entity and tables. Now this is subtle. Okay, when we are talking about database design, we tend to use the word entity. Okay, and an entity could be essentially something which we store data about. So it could be a living thing, so student, teacher, employee, something along those lines. It could be non-living, could be a product you buy from a shop, it could be a car, it could be anything that's physical but not alive. Or it could be a concept like a sale, an invoice, a stock count, things like that. Okay. Every entity will have information about it. So a student, for example, will have candidate name, candidate number, their name, their date of birth, blah, blah, blah. A product might have product name, product price, stock counts, etc., etc. Okay, so every entity will have properties, attributes that will describe it. And then when we actually come to create the entity, we turn it into a table. So the key difference between an entity and a table really is the implementation of it. So when we're designing it, we talk about entities. When we are implementing it, we talk about tables. Now I'm sure there is another explanation for that. I like to think of it in that way, so I might not be 100% correct on that one. I've never really researched it, but I think it's a clear distinction. Okay, designing is, we talk about entities, tables we talk about implementation. So for example, when we're looking at SQL, which is another unit in the A level, we talk about tables only. We don't talk about entities at all. But when we're talking about database design, we talk about entity relationship diagrams, so we tend to use the word entity a lot more. So that is my kind of quick way of explaining it. Whether it's right or not, I apologise if it's not, but it's just an easy way to think about it. So Relationships is basically, as I've already said, is how those tables are related together, and the way we relate two tables together is the use of foreign keys. Now here's an example. So first of all, please pause this video now. Okay, have a look at this. Can you identify the primary foreign keys? So pause it now, see if you can identify them. So let's go through the answer. The primary keys are these. Now, it's quite easy to spot primary and foreign keys because it's very common to put ID after it, or that it's fairly obvious it's going to be a unique value. Numbers tend to be the most unique things, or codes, for example, would be the unique things here. So in the artist table, we've got artist ID. In the album table, we've got album ID, and you can see the pattern there. It's kind of nice and easy. Foreign keys can be a little bit more subtle, but remember the secret behind it. The foreign key is going to point to the primary key of another table. Therefore, we just look for, now that we know what the primary keys are, look for where those foreign keys exist in other tables. So the artist ID, you can see, is here in the album table. And we can see the booking agent ID is in the artist table. So straight away, we've got two foreign keys here. And you can then see the relationship between them. So an agent could have many artists, and that makes sense, doesn't it? Because an agent might work with many different music artists. An artist might release multiple albums, because they can. However, an album is only ever released by a single artist, and artists will only have a single agent. Now, obviously, the real world might be more complicated than that, but for this example, we are just going to go with that.